Recording is on.
Michael, I guess you're the guy I just added to CAREX, Google Groups.
No, that's right. That's right.
Well, good to see you.
Yeah. I live in Mississauga, northwest Mississauga.
Okay.
There's the masked man.
Looks like he's getting more stuff put together in the shed. Wow.
I was going to say we can all go home now. Dave's here, right?
Yeah. Well, you look like your cat. What's in the cup? Kevin's is exposed. I don't know. That's a pretty dark whiskey you got going there, Kevin, or is it rum?
Oh, you can see that?
Well, when you take it to your lips, I can.
Oh, okay. Oh, yeah. No, sorry. I thought it was just sitting there. That's cognac, actually.
Okay. Oh, I'd love to have my cognac. I only got a little bit left of my best ever stuff. I've been savoring it for about 4 years now.
Well, my daughter and son-in-law bought this French cognac I had never tried before last year for Christmas, and I ran out, so I had to get some more because it's really good.
Remy Martin. Excellent.
No, it's really weird. I've never seen it before.
Well, if Napoleon will come down right now and have some with you. Oh,
I don't know. Have you ever seen this? I don't know. It's really nice, actually.
I'm afraid I'm going to have to make a run to the liquor store pretty soon because I'm just about out of my whiskey.
Well, how's the keg supply doing?
Well, I finished mine about 2 weeks ago, but my son has a keg here, and of course he can't come over and visit. So I've been trying not to drink it all on him, but it's hard.
Phil, you're muted. You're trying to talk, Phil? You're muted.
I muted myself because those were the rules, and I forgot. I was just going to say this is real rum. I've been out of rum for 3 weeks, but I got some today, so I'm back in rum.
Oh, you're back in action. I'm going to have to go. I mean, what good is a bar if there's nothing on those shelves?
We actually got a bottle of champagne today, knowing that Biden was going to take over at noon. But we're going to have a glass of champagne this evening.
Oh, well. Yeah.
Yeah, I'm looking forward to some really boring government news in the next 4 years. It's like none of this crazy tweet storm.
I'm looking forward to not watching the news for about a month. I've been watching it too much.
And not missing anything.
And not missing anything.
It's all the TV.
You notice you can watch the news every day, the whole thing for a couple hours, an hour, whatever it is that you're doing. And when you think back on it, they say the same thing day in, day out. It doesn't matter whether it's Trump or the virus. It's always the same. So if you turned it off and didn't watch it for a week, you didn't miss anything.
Yeah. Yeah, some of the numbers changed, and that's probably about it.
Yeah.
So are we a go, Ken?
Yeah, let's have a go. Who we got here? Frank, Peter, Kevin, Michael, Al, Dave, Eric, Phil, Dwayne.
Have all their video feeds dropped?
No. Oh, Drew's there as well. P3 UIN. Ken, I think that's where you hesitated.
Yeah, that's weird because I can only see Ken at the moment.
Yeah, I've got two. I don't see Dwayne or Drew.
Like, okay, Ken's gone. Now it's just you and me. Those are the only video feeds I have.
I got everybody. I got everybody.
People are coming in and out.
Yeah. But anyway.
Jitsi must be having some issues.
It's been having that for a while.
Yeah, Eric, get a Canadian call sign. Your video will work.
No, mine's the only one that's on top, you know? K comes before a V in the alphabet, my friend.
Okay, I'll do
You have to excuse me. Who's Victor Echo 3 Union, India, November? I don't recognize the call.
I just
That would
introduced
be
you.
me.
I just introduced you, Ken.
What's that?
I just introduced you to him.
Oh, I didn't hear. Sorry.
He's from
Hi.
the Terex group in Kingston, Drew.
Oh, okay. Oh, welcome to the meeting.
Hi, thanks
Okay.
for allowing us in.
Ah, there you are.
Yeah, hi.
Good. We must get going here. So, on tonight's agenda, we've got Michael talking antenna modeling. Kevin's going to talk GNU Radio. He's also going to, I don't know if you're going to have a interesting IC, Kevin.
Well, let's see how much time there is. And
Yeah.
if you want to do it, I do have a little something put together. So if not, that's fine. It can wait till the next time, whatever.
Yeah. We can do it on the mixer.
Yeah, whatever. Whatever. We'll just play it by ear.
Okay. Since Michael's got to go early, let's turn it over to Michael.
Okay.
Oh, just one quick interruption. If you guys put up your hand, do it several times because sometimes it's hard to catch.
Actually, we did a little test on that one. It looks like even if you got the icon selected, it does not stay on the screen. Even though you think it is, it doesn't. So that's why you got to keep selecting it all the time.
Just a second. I got to start this thing up, I think. Okay. Now, where's that share application window? There. Okay. Share. All right. Now, slideshow. Okay. This is a very basic presentation on antenna modeling. I know very little about this. I've modeled a quarter wave vertical and a dipole just for experimenting, but my experience is very limited, so I start from there. So anyway, so there's a number of antenna modeling programs out there. There's something called ESNAC that costs you to use. I'm not sure what the cost is. There's another program called 4NEC2 that is free, and it's pretty flexible, and that's what I've used. And both of them use this thing called the numerical electromagnetics code as a model, underlying model, and what it does, it simulates the electromagnetic response of antennas and metal structures and the like by using this thing called the method of moments. So what little I know about the method of moments, by the way, these slides are a mix of stuff I've done myself plus stuff that I got from a couple other presentations, so all the mistakes are mine. Anyway, the method of moments, what you do is you take the antenna element and you break it up into segments, and then you use this method of moments technique, or the program does rather. It's a numerical computation system that basically solves the electric and magnetic field equations. It can be used for very large systems, apparently. And you can do very detailed stuff with it. So as a brief overview of 4NEC2, which is what I used, the basic dipole formula length equals 468 divided by the frequency in megahertz. That formula doesn't give you anything about wire diameter or anything, height of ground and whatnot, but 4NEC2 does. It's called a stick figure program. What you do is you take your antenna, be it a dipole or a loop or something, and you divide it into segments. And this is a dipole up top here. the feed point, the source is here in the middle, and you divide it into segments. And the source is represented by a dot here, here, and here. So each wire segment, each wire has an identifier, like wire 1 or wire 2 or whatever, and each wire has a tag number as well, and they're divided into segments. And then the program does further divisions of the wires when it does the calculations. So typically you try to use small segment size, quarter wavelength, or rather a 20th of a wavelength is what you use typically. And you use an odd number of segments. That, I guess, allows for the center segment to be where the source is and whatnot. And you keep it simple. And what's this thing down here? It's in the way. I don't know what that is. Hide it. And you want the segment length to be at least four times the diameter of the wire. These are the kinds of modeling patterns you can get out of it. You can get an azimuth presentation here, looking from the top down, I guess, looking from the side. This would be for a dipole, looking from the side. You can get standing wave ratio curves, which are very handy. And this here on the right is the antenna view. The program produces this once you put your stuff in it, your wired segments in, it gives you those. So it's based on a Cartesian coordinate system, and that's basically the standard X, Y, Z system, where X is the width, Y is the depth, and Z is the height. So X to the right, Y right this way, and Z vertically, the vertical height above ground here. And you model your antenna, and this is a sort of a model of what it looks like when you're done. For a wire antenna above ground. A whole bunch of models you can get with ESNEC. These show up in the ESNEC program file folder, and each one of these subfolders has stuff in it, like HF beams. There's a whole whack of them, collinear antennas, multiband antennas, short wire antennas, whatnot, all kinds of stuff here. The other thing you can do, I was doing some looking. I have an R7 vertical on the back of my house. And it turns out there is an R7 model. It's for the NEC program, I think, or ESNEC, and then I gather you import it somehow for NEC2, and then it converts it. I haven't actually tried it. I have a DXV sloper out back working against my 30-foot tower. And I haven't been able to find, haven't really looked to see if there is, actually haven't really looked to see if there's a DXB model anywhere. The other antenna I have is, one of the other ones is a pair of ham sticks for 30 meters, and it's set up as a dipole on my tower. And I haven't been able to find a ham stick model. There may be one somewhere, but I can't find it with a Google search anyway. And the other thing that's interesting that I really like to find is I have a mini quad by Tom McKay in Stratford, mini quad MQ36SR. It's a 3-element Yagi with a director and a driven element and a reflector. And each one of those on either end of the element has a whole bunch of coils and capacitance hats. That means it's a shortened antenna. It's only about 10 feet long and about the same width, but it works really well for me. But there isn't, as far as I can see, there's no MQ36SR model. So one of these days I'm going to call Tom McKay in Stratford, where I got the antenna from, and see if there is in fact one he knows of. But anyway, there's a whole bunch of models. Oh, the way it's set up, you got to have a source in the antenna someplace, and it can be a voltage source or a current source. You give it a magnitude of 1 with a phase angle of 0. And the sources are treated as being really small, and there's no gap in the source. It's just a point. It's a point source in the antenna, not like a regular antenna, real antenna, where there's a wire and another wire is separated by an insulator. You don't model that insulator. You just model the thing across with the source in the middle. So like this. So Here's a simple dipole. The wire length would be W1. That's what the tag or whatever. And there's a source in the middle. And this one's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 segments that you specify when you set it up. You can do a fan dipole. And it's all a matter of putting the geometry together to in the 3D display kind of affair. So anyway, you can do all kinds of stuff. You can set up all kinds of antennas. I know Dave's done his wire antenna this way, and you can do all kinds of stuff. You can also represent transmission lines. I haven't done this, so I don't know very much about it, but you can do it. So, see, the source here is down at the bottom of the transmission line. There's your antenna with the 3 segments, or three tag pieces, and there's the source down the bottom here. So I haven't done that. So this is the main input for NEC2, and this is your file open stuff, save, all kinds of stuff here. There's a calculate setting that you use to calculate, and you can set it up to do a frequency scan, which gives you SWR. You can set it up to do near field or far field, depending on what you want to do. And so that's the main input. When you click on File, Open, or Edit, you get a number of things. This is one of the edit things. And here, this is setting up the wire segments. So the first one, wire 1, has 11 segments, and it goes from these are the X, Y, Z coordinates. So this antenna is at the origin. Its length is L1, which I'll get to in a minute. It's 20 feet up, and so that's the starting point. And here's the other half of it, 0, L1 plus L2, and so that's the first length and the second length, and it's 20 feet up. And you set it all up this way with 3 segments. And there's another thing. This is the geometry tab. There's a tab symbols that allows you to say, okay, L1, the length of L1 is 1 foot in this case. And it's the midsection. So this is the middle of the antenna. If you look at this picture, this is down here from either side of the center of the antenna, 1 foot and 1 foot left and right. And L2 is 32.5 feet. And the reason it's 32.50733 is because this has been optimized. One of the things you can do is pick some standard length. So you could pick 1 foot for the center section on either side, 32 feet, let's say, for the right-hand segment out the y-axis here, and 32 feet here. And then you can run the program, and it gives you whatever SWR it gives you. Then you can optimize it on, let's say, L2, the length of L2. And what it does, it grinds through a whole bunch of calculations and comes up, and you optimize it on, let's say, the SWR, and give it the frequency, and it comes up with an optimal length, and that's why this funny length. So sure enough, it's telling you that each half of a half-wave dipole is 32.5 feet long, 33.5 feet long, 67 feet altogether. The other thing you do is you give it the frequency, which in my case I wanted minimum. I wanted the minimum star is 7.05. You give it. There's a number of choices of ground, real ground, no ground, all kinds of grounds you can use, and the whether it's free space or not, and you can tell it whether it's sandy soil or water or whatever in terms of what the main ground is. And the other thing, there's a source and load tab here, where you tell it the source is 1 at magnitude 1, 0 phase. You can also tell the program, I want to use number 14 wire or whatever, or I want to use number 14 wire insulated, which has some minor effects on the results. So that's the kind of input you get, you put in. And this is this is the SWR curve for this antenna. which is pretty good. Oops, where'd it go? So it's minimum SWR is at 7.05, and it's 1 point something, 1.2 or some such. So that's one output. The other output you can get is the far field pattern, which is what this is. And because this antenna is only 20 feet above the ground, most of its darker colors are high radiation, so the radiation is mostly up, which I guess is what you expect with a dipole that's too close to ground. If you put this up higher, 100 feet or so, you get a different pattern, a more ideal pattern. So that's just about it, I think. That's everything I have to say. Very brief, but it gives you some idea, I guess, of what you can use it for. So I'm going to turn the screen back to unshare it, okay?
Okie doke.
Did I unshare it? No, I didn't.
Yeah, you have now.
Okay, good. Okay.
Okay. So has anybody got any questions or comments for
I hope not.
for Michael?
I hope not.
Okay, go Dave.
Uh-oh.
Mike, those measurements were in feet?
Yeah.
Did you set the program to know it's in feet?
Yes, I think I did. That's right. You do. There's a way that you tell it, that you can either do it in feet or meters.
There's two places you have to set it in feet, and you'll get bitten if you don't set it in both places. One is off the main screen. There's a settings tab, and then in the wire screen, you have to go down to the bottom, or in the I can't remember if it's the wire or it's in the symbols down at the bottom. I think you have to tell it what the scaling factor is, whether to scale it from feet to meters or from meters to feet or something like that.
Mm-hmm. Well, it works. I figured it was okay. I did set it up in feet.
Yeah, because I did recently. I did a simulation, and I thought I put it in feet, and it turned out to meters, and everything was working great. I was getting really good patterns, and everything was looking great. And then when I figured it out, I put it back in meters. The analysis wouldn't work. It kept crashing.
No, I didn't have that problem, but then I have a very limited experience. The other thing I didn't show you, you can actually make that antenna. You can rotate around the pattern and look above and below and all that stuff. It's pretty good. And this is only a simple dipole. I didn't try to do anything fancy. For field day one year, I built a quarter wave vertical with 2 elevated radials. The bottom of the antenna is 3 feet off the ground, and the overall length was 37 feet, I think it was, for a quarter wave on 40. And I used a flexible mast, one of the Kite Guy's masts, and it was 32 feet long, but you can't support a wire antenna that high up. It's too flexible without going it all over the place. So I ended up making it the bottom half was just a piece of wire, and the top half was a piece of 400 ohm transmission line tied with the legs tied at the top, with the short at the top. And so it was actually a sort of a loop at the top. Anyway, it worked as well, and the results were pretty good. It seemed to be pretty good anyway. So, yeah. Peter had a question, I think, or somebody.
Peter. Yeah, go ahead, Pete.
I have a couple actually. One is why the 3 wire segments and not one for the dipole, and the other one was, did you try various ground types with the same setup to see what the difference, how the antenna reacted to the different type of grounds?
Well, I guess that's the first question. I guess you've got to have a source somewhere, and that source has to be on one of the wire segments. So you can't just do left and right. You got to put a source of some length, a segment with a source in it, and you got to give it some length.
So a dipole would be 3. So the source is one segment, then the left and the right are the other 2.
That's right. That's the way I did it. That's how I modeled it. That's exactly right.
Okay. And did you do any different ground types?
Not this time. When I was fiddling around with the quarter wave vertical, I did. That was a couple of years ago. So it's possible to do that, and you get different results. Of course, the question is, well, what is your real ground source anyway? And you don't know that really. You can guess at it. So yeah.
Okay, thanks.
Okay, I think Eric was next.
Yeah, a couple of questions. Can you, I don't know if you answered this or not, but can you do a frequency sweep on a given antenna model?
I guess you probably can. Well, that's what when you do the when you're looking for the SWR, that's what you're doing. You're telling it start at one frequency, go to the other, and that's how you get it to do the to give you the SWR. It's over a frequency range, so yes, you can.
I guess I'm wondering if there's like a graphical, display of that, so you can see if there are other, resonant frequencies, like so you can see it all at once. That's kind of what I'm at, like a plot. Any idea?
Well, that's what I did. Yeah.
Oh yeah. Okay.
That the SWR plot is exactly that. Like you tell it, and well, the antenna was 40 meters, so I figured it was going to resonate at 7.05 roughly, which is what I'd figured out, and that's where I got the link to start with. So I started at 6.7 and went up to 7.5 or something, and you get the sweep, and then you can zoom in or zoom out depending on what you want to do. If it's a multi-band antenna, you could look at a range and see the dips on the various frequencies.
Okay, cool. And the other question, that last slide that you had that had the colors on it, the radiation, the lightest colors, that's where it's radiating, right? The hot pinks and the reds?
Yeah, let me go back to it here. Where is it? Can I get back to it? Application window in here. Yeah, this one. Yeah, so this is a dBi, I think it is, gain. So the blue is very low, and the darker color up the top is the highest gain. So this antenna you could characterize as an invis antenna, right? Because it's
right, straight
up, which is sort of what if you've got a dipole that's too close to the ground. The practical dipole is too close to the ground, but it works anyway. It works on it works for field day reasonably well. So
okay, thanks very much. That's great. I just want to make sure I got that the right way around. Okay, appreciate it, Mike.
And you can rotate this thing around, like when the program is live, you can sort of drag it around, and there's a viewer for this. It's the F9 viewer, and you hit F9 and you get the pattern. When I first did it, I didn't see anything. I just showed the 3 axes with the antenna. This is the edge of the antenna here. And the reason was that down here, where it says multicolor, it said no pattern or something. So you got to remember to click on this at this point to get the pattern. But you can rotate it around. You can look at it from the top and the back and all that stuff. So yeah. Any more questions? Guess not. I'll unshare then.
Yeah,
I think Phil's got one.
Okay.
Yeah, just a quick one about wire size. Never really thought about wire size for HF antennas, but probably you get up to 2 meters or 432 or something. You need to worry about the size if you're using aluminum tubing or something like that. That'd be something that you could do with that program?
I think so. As far as I know, you can. You can specify different wire sizes. You can specify whether they're insulated or not. I imagine you can, if you're building say a Yagi out of hollow tubing, aluminum tubing, you could probably, I'm pretty sure you can model the tubing as well. I don't know that for sure. I haven't done it, but I would imagine you can. You can model.
It'd be interesting to just try it at 2 meters, say a dipole at 2 meters with aluminum tubing or just a wire, see how much difference there would be.
Yeah. I haven't actually done that. I know you can do things like you can model the standard quarter wave 2 meter antenna with the basically with the 19-inch wire up from the bottom of an inverted SO239 with 4 legs on it, angled down at the 45 degrees to the ground. You can do that as well, and you can put in different wire sizes. I know that for sure.
One of the other variables was conductivity of the ground. Is there a practical way to measure that? Like, do you measure with an ohm meter, or what? How do you measure conductivity of the ground?
That I'm not sure of. I leave that to other people.
I never really thought about it, but presumably, if you've out in where it's been dry for 2 or 3 weeks, it'd be something, and if it's been raining for 2 or 3 weeks, it'd be something very different.
That's right, and you'd have to account. You could account for that by changing your ground conductivity in a simulation and see what difference it made.
Might explain why you couldn't make any contacts when it's raining.
Yeah.
Okay, that's all the questions I had.
I think Peter was next, and then Dave, and then I think there was someone else I didn't catch it.
Drew. Drew was the other one, Ken. What was it? Oh yeah, I wanted to follow up, Michael, with Eric's question. Can you take that antenna but do a scan from 1 to 30 megahertz to see if there was other areas in the HF band that the antenna would be resonant at?
Oh sure.
Okay.
It'll do it. You just tell it the length. You tell it the frequency range you want to scan it on. So you could do the whole HF band if you wanted to. Sure.
Okay. And just to answer Phil's question, you can use a megahertz, but that would tell you the resistance of the ground. I'm not sure it'll tell you exactly everything you might want to know. There's probably other devices out there to measure the soil moisture and all that kind of stuff. But a megahertz will measure the resistance of the ground.
How do you convert from resistance to conductivity, which it asks for?
That's another equation. I'll leave it to you, higher mathematical type guys to figure that one out. I think
There's a guy in
1 over R. It's 1 over R.
There's a guy in I think it was the NPARC Club in Niagara. I think it's Peter Gebhardt that was talking about a project to measure. I'm pretty sure it was to measure ground conductivity, and what he was going to measure it somehow. Not exactly sure how. I think it involved basically house voltage, 120 volts spread out over a distance or something. I don't remember the details. I remember reading about it somewhere. So there's ways to do that if you know how to do it properly. But my thinking this is academic because you can't do anything about it anyway, right?
If you're measuring the resistance of ground, what do you measure it in relation to? Ground?
Yes. Well, you are. For example, I'll give you the example. What we did in the electrical trade is you're measuring the resistance between 2 ground rods. And there's I can't remember what the number is now, but there's an acceptable resistance. And if it's too high, then you got to drive yet another ground rod until you get it down to the low thing. What you're not supposed to do is pour water on it, because the inspector will find that, and then you will fail for sure. Anyway.
Okay, I think Dave had his hand up.
Okay, so come back to wire diameters. There, Michael, did you talk about optimization?
You can get the program to optimize on what Ed Spingola and I did. We optimized it on the length of the arms, not the center where the source is, but the lengths on the 32.5 feet on either side. You can also optimize on conductor size, I believe. It'll do it.
Yeah,
I think it'll do it, yeah.
Anything in that wire window you put in, you could put a variable and you could optimize it, and there are various forms, not just optimization. You could do a sweep between a bunch of values from a low to a high and do a sweep and just vary that. So for example, if you want to try different conductor sizes, you could sweep that. You can't go from aluminum to copper though. You got to do it for aluminum and then you got to do it for copper. Okay, and then with respect to measuring ground connectivity, I just, in one of my ARLL publications, I just saw a circuit that allows you to do that, where you build a circuit and it allows you to measure. It comes out like, I can't remember the unit, Siemens per something or other. It's a weird symbol and a weird unit you've got for connectivity.
Siemens is the latest unit of measurement for Mohs. Apparently, Mohs is now out of style. They've changed it to Siemens.
Yeah, so there.
IC rules, yeah.
Yeah, there is a. If you look in the program, hang on. Let me just look in here and see what the. Oh, jeez, frig. If you go into your ground measurement, yeah, you got to put in connectivity and the dielectric constant, right? And so that, I believe that circuit that the ARRL has, I saw it somewhere. It might be in the grounding and bonding book, but it's in one of those books I got, and it's got a circuit that you build, and it helps you measure that for your ground.
Mm-hmm. It's a pretty flexible program for sure. I just haven't really played with it to speak of at all, but I know you can do all kinds of stuff with it. Dave, you also modeled, in the presentation you showed us last time where you had your long wire, you had modeled the ground mesh. Hadn't you put down a ground mesh and with chicken wire or something? Did you actually model that in the program?
Yes, I did. The other thing I was going to mention about segments, okay, don't bother putting in segments. Just set it to 1 and go and turn on auto segmentation, and it does it for you. You don't got to figure out these segments. The program will optimize it, and when you go and run it, it pops up a window and it tells you how it's going to segment the antenna, and it optimizes the segment. So I always use auto segmentation, and it's always worked. I've never had a problem, except the meter and feet thing. I'm telling you, you're going to burn yourself using that, because for a wavelength, you have to have a minimum size. And if it's smaller than that size, the program pukes. And I think it's wavelength divided by 1,000. So if you have a really long wavelength and a short wire, it's going to puke. Because you can't get enough segments. You can't get a segment size to match that rule. And if you go on there is a document, a 4NEC2 document. It's really good. It's a user manual. It goes through everything for you, including all the error messages you can get with a plain English description. If you go and you Google 4NEC2 user manual, you'll come up. I think there's 2 of them. One is an online web version, and one is a PDF, and they're both very good.
I think I saw those at one point when I was looking around. Yeah.
Okay. I think Drew, did you have your hand up?
No, that's okay. I think I've discovered my answer. Thank you.
Okay. I just noticed something, guys. When you put your hand up, they now have an icon in the top left corner of your video box. So it's easy to tell who's put their hand up. Okay, very good, Michael. Appreciate that presentation. Got a lot of talk, like 20 minutes. Holy smokes. So up next is Kevin with Gnu Radio. How can you talk like that?
How can you GNU your GNU Radio? Yeah.
Yeah.
Well, this was as a result of this Hack RF thing that I bought off of I don't know if it was eBay, AliExpress, whatever. Because Peter had bought the plain, I call it the plain one. It was like it's a clone of Osman's original one, and then they have this PortaPack thing. So anyway, that's that, and I wanted to play around with it and just see what it can do. So this is a little taste of what it can do. So anyway, let me without further ado, let's do this. Okay, everybody see that jumble mess of screen there?
Mm-hmm.
Let me just, we'll just make that the dominant one. So anyway, yeah, it's only 6 slides. Don't worry, it won't take long. But so I just wanted to try this replay attack. I don't know if you go on YouTube, there's like a ton of these videos about people hacking car fobs and garage door openers and all that. Okay, well, how hard is it, right? So anyway, that's what I wanted to try, and that's what this is kind of about. For anybody that doesn't know, a hack RF is an SDR with 1 megahertz to 6 gigahertz response, up to 20 million samples a second, and I think that's limited more by USB than anything else. The samples are 8-bit quadratures, so each sample has 2 bytes, and it's half duplex. It can't do full duplex. So you're either transmitting or receiving, but not both at the same time. And then what somebody did was they said, you know what, we can, this isn't very practical if you want to go and do field stuff. So they said, somebody decided to make this PortaPack thing. And then so they threw the hack RF in a case. They put a touch screen on it, a real-time clock, an SD card, some operator controls, and a headphone jack. And they threw some firmware in there with precompiled programs that run in the hack RF. And the result is this thing here. So you have this little screen. My picture didn't turn out very well, but there's a little an encoder wheel here with 4 buttons around the side, an antenna port. You can bring in an external reference, some LEDs at the top, and a place to throw in an SD card. It's got a bunch of stuff in the firmware, things like you can set up a little transmitter from a microphone and a standard like headset. You can transmit Morse code. You can receive ADSB transmissions, and you can even decode the tire pressure monitoring systems, which I did not so much here, but at the cottage where it was a little bit RF quieter. As certain cars drive by, it would show up, a Ford at like 30 psi or whatever. I thought that was kind of neat. It only does a few different cars. It doesn't do many. So that was kind of interesting. It's got a signal generator in it, various waveforms, a signal scanner. You can give it a range of frequencies. It'll sit there and look for whatever, anything at all, FM, AM, whatever, and a bunch of other receivers and stuff. Some things work a lot, not so much. And as we all know, a good antenna is important to be able to do anything useful. But you can see it's got like a little screen here, and you scroll around, you can transmit, capture, replay, calls, a scanner, utility stuff for your SD card, some settings, and hack RF, which puts it into the original hack RF mode. So anyway, that's what this did. And so what I wanted to do was try this with my garage door opener, just because it's, they say you can do it. So, okay, let's see if it works. So anyway, so I did a little video here. You can see, so you tell it to go capture, and I'm fooling around with the wheel there. It's set to 315 megahertz, which is the frequency of the garage door opener. I hit the button, so it captured something there, and then I stopped it. So, okay, that's fine. So it gave it puts a file name on it. You can control, these numbers are for the gain and whether the RF amplifier is on, and then the bandwidth, that sort of thing. So anyway, on here I gotta let me do this, and then I went out to the garage, and by the way, to do this replay attack, the way it works is that you capture a signal from your device, your key fob or whatever, but you do it out of range of the device that you want to capture it of. Otherwise, you have to jam the signal. So in other words, you're taking a signal from the in this case, my garage door opener, you're taking a signal that the garage door is not seeing, right? So it's still a valid signal because there's something called rolling code generators. So anyway, then I went out to the garage, set it down, and then I selected the file to play, and it's kind of blurry there, but once I figure out what button to push, the user interface kind of sucks. But then you go open file, and you can see it plays the file, and it opens my garage door. So it works.
Oh,
So yeah, it works once. Because there's this thing called a rolling code generator, you can't use it again, which is good. This is important, right? For security. And I did try that. It's like, okay, I'd recorded a couple of presses, and you record a couple of presses, okay, then it works. But after a while, it gets out of sync, and I don't know how my particular garage door opener is set up, but some of these chips, there's a chip by Keylock, that it will allow up to 256 random codes that it kind of tacks on the end. So in other words, if you press your device like 200 times, it'll still sync. But if you go like 257 times, you have to repair it with your device, your garage door opener or whatever. So that's how they kind of get around to it. But this one, I don't know what it's doing because it's got an 8051 chip in it. Or sorry, it's got an RF transmitter that has an 8051 microprocessor, plus it has a PIC 16 in it. So I don't know what they're all doing in there. But anyway, and so that was, okay, fine, it does that. That's cool. And then I thought, well, what if can I do this on my own, right? Can I make something just with a hack RF that does this exact thing? Because I thought, well, how hard can it be? And actually, the answer is it's really easy. There's most of these blocks are actually variables for running and setting gains and stuff. The whole program is 4 blocks, and 2 of them are for displaying stuff, the frequency and the waterfall. So really, you can do this with 2 blocks: the source, which talks to the hack RF, and a file sync. That's it. That's all you need to do this to capture, and this captures the RF data, right? And if where am I here? Oh. And this is the program here, and oh shoot, I don't have it. Okay, you know what? I can plug it in. Let me just. So if I go and I run this, and why isn't it running? Oh, because I don't have the hack RF mode set. Hang on. Okay, now let's try it. Oh crap, it's on the wrong screen. Let me pull it over there. So there you can see the hack RF running. And as I press the key fob, you can see on the right there, the little colored dots coming up. And so it's capturing that anyway. So that's really all it takes to do that part. Then I thought, okay, well, then I got to replay it. That's got to be more complicated. And nope, it's actually, again, fairly simple. In the last time, it started into a file source, and then you just have to put it out to the hack RF. Now, the signal level that you record is actually quite low, obviously, because you're just recording a raw RF signal. So put a little gain on it, and then send it back out to the hack RF, and away you go. And it's the same thing again. It's quite simple. And if I tell it to do that and turn it on, then because it's playing a recorded file now, which, oh crap, it's going to be a different file. Because I just recorded over my file I was using. Should it work? It should still work. No, it's not coming up. Okay, I overwrote a file. Anyway, so that's that was that, and then I thought, well, what if I wanted to like decode the bits and stuff? I thought, that looks a little bit more challenging. And it was a lot more challenging, and it's still not working. So anyway, I spent a lot of time over the weekend trying to figure out how to take the signal from the file source. You know, you have to throttle it, and then I have some, you know, I started looking at it and doing some things, putting it through this frequency translating filter. So basically it takes it from 315 megahertz down to some lower frequency that you can pick out and basically channelize it. And then a low pass filter, you get the magnitude, set a threshold, put a constant, and that all these are to, you know, trying to clean up the waveform and balance it around 0, because this clock recovery block wants it balanced around 0 with a maximum amplitude of 1 each way. And anyway, and then this binary slicer is supposed to give you some bits and that you can record in a file and then look at it. And I thought, okay, well, and that doesn't really quite work so well like that. So I ended up with a you know, sort of a printout or a view on the scope that looked like it was Manchester encoded, but again, I couldn't get the Manchester encoding done. There's no block I could find that actually does that, except for this clock recovery block, but it's now deprecated in version 3.9 of GNU Radio. So anyway, it's a work in progress, but it's like the actual process of capture replay is quite simple, but the you know, the way they go on, like Michael Osmond and some of these guys that really know what they're doing, and they start decoding, you know, restaurant pagers and all this kind of stuff. It's like, it's a lot more complicated than at least what I thought it would be. But anyway, so that's that was my experience with that. So in some ways it was easier than I thought. Some ways it was a lot more complicated. So, but a couple of things, as always in the SDR world, sample rate is really important. You have to know why you're sampling something and why not. And also you have to watch that you don't sample too fast, because, you know, you've only got so much computing power and so much disk space. And when this thing records, it's recording 2 megabytes per second, right? So, 4 megabytes per second, 2 million samples, 2 bytes each sample. So so you let it run for an hour, you know, fill up your disk pretty fast. So anyway, I found the block documentation was very spotty. Some of the stuff is there, some of it's not, some of it's deprecated, some, you know, you go to 5 websites, you're going to find 5 different solutions for how to do something. And then unless you know the characteristics of the signal you want, trying to get the right cutoff values for filters, stop bands, clock recovery blocks, like the gains in there and everything. If you don't understand it and don't know it, it's going to make it makes it very challenging. And and you learn a lot. So that was that part. And there was a couple other little things. Just it's interesting when you, and Peter, you'll probably appreciate this, having a hack RF. When you go and plug it in to plug it in and run it from the black, you get this little display, and it shows the center frequency that you're running. It shows the gain of the the IF gain. It shows the bandpass filter setting, and it shows it in real time, the RF amplifier setting, and also as you change them, it updates them, so you can kind of see how your thing is set up and what frequency you're running on, which was really nice actually. It confirms that, you know, what you're sending is being received by the hack RF. So anyway, that's my experience with my very limited experience with GNU Radio and hack RF for now. So any questions? Cool. Oh, VE3UIN, yes, go ahead.
Yeah, hi. That was a really interesting discussion. I also have a hack RF. And,
oh, good.
I recently pulled down some SDR software for it. That just a package off of one of the SDR sites, and it contains GNU Radio as well as some other SDR stuff. And I was intrigued about your discussions about the door opener, because I have 2 versions, one elderly and one not, that are at very different frequencies. I was kind of hoping you were going to be able to hack the new one because I have 2 new ones and 1 old one. The 2 new ones won't work with my system. I was going to use the hack RF to try to investigate exactly what that was. But I was wondering, when you do the GNU Radio program, you then feed it into the PortaPack through your SD card?
I just plug it into the USB power supply, right? So my laptop's supplying power to the hack RF / PortaPack.
Okay.
And as to your thing about decoding these and all that kind of stuff, the really old garage door openers are simple. They have a dip switch. It sets a code. That's it. Those are, as far from what I understand, they're gone. Everything now is rolling code. My garage door opener works. My capture replate does not work on my Subaru. I don't know why. And that's why I wanted to decode it, because I wanted to try and kind of figure out why, but it doesn't work on my car.
They already put a fix in on that because people were running around swiping cars using this sort of system.
Yeah, and that's why I thought, it'd be interesting to know why doesn't it work. But anyway, it's more sophisticated than the garage door opener, which I'm glad. I don't want it to be easy to do. I don't want some guy to order a piece of hardware from China for $150 and steal my car, right?
Well,
or anybody else.
I think it's certainly quite capable. This equipment's very interesting.
If you're smart enough, I'm sure that you can, do more with it, but it takes some dedication and some time.
I was going to ask you about the PortaPack before I let you go. It contains a battery pack in it?
No, mine does not.
Okay.
I just use I have one of these little USB battery things. I just basically have elastics around it, and I strap this on the back.
Absolutely. No. Okay. Thanks.
And it becomes really portable.
Oh yeah, absolutely. No, I was just wondering about that. Okay, that's great. I see Peter's got his hand up, so
Peter's got his hand up. Go ahead.
Okay, go Pete.
I always got something to say. Well, 2 things. Well, it sounds like you're on your way to making your own PortaPack. Too bad you didn't discover this stuff before you bought the PortaPack in a way. But that's what you've done, because you got the capturing and the replaying back down pat. Now, the other thing too, though, is I see, you were messing around with the garage door. So breaking your garage door is one thing, but I wondered if when you were going to try your car. So you did try the car out.
Yes, didn't work.
You don't want to break that, though.
No, I don't want to break it, but it did not work. Yeah, I did the same procedure. Okay. No, it did not work. No, I couldn't unlock my car.
Interesting.
I tried it. I don't know what, obviously they're doing something, and I don't know what the something is. Yeah. So, or else I just messed it up and I was just being incompetent. But I'm glad it didn't work. I didn't push it. I
remember Mike Osmond a couple of Daytons ago talking about this sort of thing to Dave and I, but I can't really kind of remember all the details of what he said now. But it was interesting anyway. Okay,
it is cool. I mean, it's it's kind of neat. It's amazing what you can do. Like the possibility. Like I said, even the tire pressure monitors. It's like, so what? It's like not a big deal. But A, you can check and see if they're working. B, if you were to be, if you're so inclined and you had a camera in front of your house that monitors the street, and then you took this and recorded all the cars that went by, now you have a license plate associated with every specific car that goes by, because there's a MAC ID associated with all the tire pressure transmitters.
Well, it's interesting because I didn't want to spend the extra money to put the sensors in the winter tires for the wife's car. So during the winter, it just can't.
It's anonymous, eh?
I have to buy this device, sweetheart, because it's important to read your tire pressures. Thanks.
Okay, go ahead, Phil.
Where'd Phil go?
I don't know. He just disappeared.
You must have hit the wrong button.
Yeah, probably.
Well, it is hard. I know, I don't like the way they have the screen design, because you have the mic button right beside the leave button. And if you just slip a little bit over, you're gone, right?
There he is.
I hit the go away rather than hitting the mute. Do you recall what frequency the PortaPack said that your tire pressure gauges were on?
I forget. I was just messing around when I was on holidays in the summertime there. I think it's in the ISM band in either 315 or 433 megahertz or something. One of those two.
And if you don't have a Portapack in the HackRF GNU Radio world, or mostly the GNU Radio world, I suppose there are programs or libraries out there that somebody's already figured out how to do the tire pressure.
There are some, but again, it involves decoding the bits for that, right? I mean, that's just reading stuff. So it gets down to this bit decoding problem. And, is it on-off keying? Is it frequency shift? I mean, that kind of stuff is easy to figure out. But then to slice up the bits and recover the clock and then figure out what they mean is the real challenge.
But hopefully somebody else has already done that and has got a little program out there that is done.
It's possible, and with the Portapack, it's actually on GitHub, and they tell you how to compile, and you can create your own. If you create a GNU.
Recording is on.
Just to clarify, I think the two files that you use to record and play back for your garage door opener is a GNU Radio file that you can download directly in or use directly with the HackRF. You don't need to use the Portapack in that case, correct?
No, that's correct. If I'm recording it in GNU, and I didn't actually go look at the files that the Portapack recorded, but I'm pretty sure they're just plain old, GNU. The way the regular file sync block works, the file sync and source, they're just rather large files, and yeah, it's just a whole bunch of bytes, right?
And just one other thing that I think I was reading something somewhere where the latest version of GNU Radio does not have the Osmocom block in it. Did you recall something like that?
I don't know. I'm still running 3.7 because it seems, the newer versions, they're deprecating some of these blocks, like that clock recovery block is deprecated. Mm-hmm. I don't know what the replacement is, but that clock is apparently that block is useful for doing this kind of stuff. I just haven't figured out how to set it up so it works.
Okay, thanks.
Okay, anybody else? Anything for Kevin? I guess that's it. Good. Oh, excellent, Kevin. That was interesting. It's much like the RFID scanners. Guy walks by you and picks up your codes off your card.
Well, actually, if you want me to do the chip thing, that's exactly what I'm talking. What I have. You should bring that up.
That's why I have an RFID wallet.
Oh, a blocking one? Yeah, mine too.
Yeah.
But if you want, I can do that now too. It's only like 3 or 4 slides.
Sure. I think we got time.
Okay. Phil wanted to say something. Go ahead.
Oh, go ahead.
Oh, where'd he go?
I think he hit the hang up button. I'll be here in a sec.
Is he muted?
I think he may have hit the other button again. There he is. Hello, Phil.
This is bad enough. To do it once is bad. To do it twice.
I think it's the rum.
Yeah, it could be. Glass is empty. No, I just searched on the internet for GNU Radio tire pressure, and there seems to be a lot of it. At least one from GitHub. And it looks like it's got all the stuff there you need. So I sent the link around there on the chat.
Oh, okay. Oh, I didn't have the chat open. Okay, I recognize that name.
Jay Boone.
Yeah, I recognize that name. He's involved in this Portapack too.
Yeah, well, it could be that you can do the tire pressure directly on your HackRF. So I'll try that sometime.
Yeah, it was interesting. Like what was in the Portapack worked. It grabbed a few cars as it went by, and I thought, oh, that's cool. Gives you a little, and you can record them if you want. It's like for whatever that's worth. Anyway.
Okay, thanks.
No problem.
Go ahead, Drew.
Well, it's handy to know if yours is working.
Yeah, exactly.
They want $75 a piece for one of those things, and if it goes bad on you, then you get to be plagued by all the error messages from your car.
Yeah. Yeah, exactly. And I have it on my motorcycle too, and it's like even more to replace that. But it's like I just wish you could program it, without having to pay them to do it. But anyway,
Well,
I'm sure that
worth
software's
bit.
worth a few $1,000 too.
I have no doubt that they're very proprietary.
Yeah. So anyway, if
Well, it's
anybody,
interesting that your car wouldn't allow you to get near it.
well, I may
Indicates
have
that
messed
they've
it
already
up.
figured this out.
Yeah. And
I
I'm
suspect
glad. I'm glad they
this has
have.
been on the air for 2 years. Yeah, well,
Yeah.
that's right. It's been on the air for 2 years that people have been able to steal people's key fobs.
Mm-hmm.
Basically record the material coming off a key fob and then go and start the guy's car. And I
Yeah.
know with my wife's kicks, you can't do that because you do have to have the key in your possession or it will not move.
Yeah. So
Doesn't matter about the radio. You can open it, but you can't move it.
yeah, see, mine wouldn't even open. So either I messed it up or it really does. It is doing something a little more intelligent than just a rolling code. So anyway, is that it for the Hack RF stuff?
Just a comment, there's been a bunch of people around here who've had their cars stolen. You hear about this all the time. People get their cars stolen right out of the driveways because of exactly this.
See, and that
scanners.
it's in. I know we're all talking about this, but I actually went and did a little bit of. I forget what site it was on. It was some police website or something like that, and they were talking about or insurance. Maybe it was an insurance website. They were talking about the most common way of stealing cars, and it's actually not this. Apparently, the most common way they're running into is that they're buying a key fob from Canadian Tire or whoever, like the $20 key fobs that you can buy, and they're reprogramming the car to accept the key fob through the CAN bus port. That's actually the most the most common way, because it just takes a little bit of time. It takes like half an hour or something for it to take and do whatever that they're trying to hack into. But once you do that, you have your own key fob and away you go.
Wow.
So that apparently, if you can get access to the CAN bus port, which is on every car, then they're apparently quite successful doing that. So anyway,
Okay, Eric and then Dave.
Is that the genuine Hack RF one you have, or one of the knockoffs?
no, it's a pretend.
You find it works just as well? Well, I
don't have a good one.
Right.
Yeah, I don't have one to compare it to, but it's done everything I've asked it to do. Now I haven't tried anything at like 5.99 gigahertz to see if it works okay. I haven't measured the output power or anything like that to see if it's doing what it says, but it seems to work okay.
Yeah, you've been happy. Like there's been no roadblocks. Yeah.
For $150 toy, it's fine.
Yeah. Cool.
Like a real one is like closer to 500, right? By the time you get over here across the border.
Okay, go Dave.
Yeah, I got to find a mute button. Kevin, it was interesting. About 2 years ago, I was at a presentation with a bunch of researchers who were demonstrating how to get into a CAN bus, how easy it was. And this was, I don't know if they changed it now, but some of the older cars, the Wi-Fi, because cars come with Wi-Fi now, has a Wi-Fi hotspot, right? So the Wi-Fi is connected to the CAN bus. So if you can get into Wi-Fi, you've got access to the CAN bus.
You're good, yeah.
And so they were showing how they could go and cause a car to break just by, they didn't go in and do a lot of things, because it was just a proof of concept.
That was on a Jeep, wasn't it?
Yeah, and they said, look, we could make the car break.
Yeah.
Now, what is the CAN bus? What exactly is the CAN bus?
That's the vehicle controlled bus. That's what all the sensors and everything the vehicle's connected to.
Yeah, it's every car uses the CAN bus. It's a differential type serial bus that can also supply power to devices. So and it's 5 wires. So instead of running control wires everywhere and power wires everywhere, you run like a 5-wire CAN bus. You plug into it, and away you go. And you can set up different nodes. I think it's 128 nodes per segment or something. Anyway, it's used in industry too a little bit, Not so much now, but it used to be more popular.
It's on boats.
Oh, they got on boats too?
Yeah, I keep
Why not?
seeing. That's where I've heard the term, but I keep seeing people with Volvo motors and the like, and sailboats, and they all talk about a CAN bus system on their motors.
Yeah, why not?
Well, it's a lot of money
For that kind of stuff. Yeah, it's it's too slow for industrial stuff these days, but still, it does just fine for that kind of thing.
I'm glad I drive an older car.
Hey, Eric, I don't know if you remember the last time we were at Dayton and we were talking to your buddy, Rex.
Mm-hmm.
Remember Rex? He was looking at doing some work with CAN bus. He wanted to build some kind of a CAN bus sniffer device. And I told him they exist.
Yeah, they already exist.
He had some kind of spin on it he wanted to go and build.
Yeah, I think he was working on doing an engineering project for somebody who's doing retrofitting of vans for like wheelchairs. He wanted to integrate the CAN bus into it. I believe that was his project. So, yeah.
Okay.
By the way, but since we're talking about Rex, I just got a message from him a couple days ago. You probably saw it too, Dave. His beloved dog, Crystal, of course, died recently. So that's a bit of sad news. So Crystal is no more.
And 2 years,
Good name for a dog.
2 years later, we're still waiting for the buildathon
Yeah.
from 2019.
He's working on it. That's why we're friends, don't you know?
Yeah.
When I get my Canadian call, that's when the kit will be done.
Okay, so do you want me to still do this chip thing? It's only a few minutes, but it might stir up a conversation. I don't know. We'll see.
Yeah, go ahead.
Okay. All right.
Okay.
So we'll okay. Oh, come on here. Did it come up?
Yep.
Okay. All right. You can see. Okay. Hang on. Sorry. That was me not doing my thing here. Okay. So, okay. So anyway, and I went down this rabbit hole. I've heard of this stuff. I don't know if anybody's heard about it. They talk about this smart dust with all the vaccine talk and the 5G and injecting chips and all this. I thought, oh, there's got to be something behind this, right? So I thought, okay, well, they could be cool chips if they exist, right? So I went down that rabbit hole. So what is smart dust? Well, some people would have you think that there's these miniature chips that are typically RFID that can be used to track position of objects. And so this little picture here shows those are grains of salt. And these are supposedly smart dust chips that may be made by Hitachi. These links that I have here are talking about Hitachi making these tiny little RFID chips. And by tiny, 0.15 millimeters by 0.15 millimeters. So that's only about 7,000ths of an inch square and 7 microns thick. That's pretty small. And I took this off of Snopes.com, which I don't know if anybody knows Snopes. It's a website that tries to provide research and data for, conspiracy theorist stuff. Peter, you think you can solder that? All right. Okay. That I want to see. You're going to need that microscope you wanted to get. So anyway, that was the beginning of the rabbit hole. And I thought, do these things really exist? Like, is it even possible? Right. And so anyway, I took this off of Snopes. Just, they said they had back in 2001. So a 0.4 by 0.4 millimeter with an antenna. So, okay, fine. Then they got a smaller one, 0.15. Then they got an even smaller one, 0.05 by 0.05. I mean, that's like, I know you can't solder that, Peter. I'm sorry. But it needs an external antenna to function, which is several millimeters square. So maybe this one you could put through a needle, okay, and inject it into somebody. I don't know. Keep in mind, these are all passive RFID tags that derive, the energy to transmit the data comes from the local RF field that they're receiving. There's no batteries in them, right? And I went looking for data sheets. I thought, okay, well, if these exist, there's got to be data sheets, right? nothing. The number 2 hit on Google, which came from a website called, let's see here. I'm going to put it in the, no, that's not it. I think it was paulmaguire.com. So the website came from, it was linked to this guy. He was linked as the author of the PDF because I went and looked at the PDF properties. There was no revision info, no publication date, no copyright info, no document security. And if you go look at that website, you'll agree that he's not a technical person that should be writing data sheets. So it was a fake data sheet on that. And it was the number 2 hit on Google. I thought, that's pretty good. So if anybody starts to go looking for this, they're going to think that it's real. And it looks like a real data sheet. I mean, he did not a bad job cribbing it. So anyway, so I'm getting kind of doubtful by this point whether these things even really exist. And actually, what I thought, what does exist, right? So there's this company called Locator, and they make GPS tracking devices, and they can track their chips at over 100 meters away. That's fine. These are active RFID tags. They have batteries and stuff like this. They have real antennas. They're not very big, but they're still like centimeters big, right? Not fractions of a millimeter. You can get passive RFID tags. AliExpress has them, but they're like, 3 inches by an inch. That includes the antenna. Maximum range, 7 meters, but they're only $1 each. So, you can get stuff that you can read from a distance, but it's not, miles or kilometers or anything. And actually, this was the picture that started me on this whole thing. It was in one of the tech magazines. That's a US penny. That's a temperature data logger that you can buy right now. It's available. It's got a battery. It's got a solar cell. It's got an 8K memory, a microprocessor, and a very accurate temperature measuring device inside. Again, the battery lasts for hours to weeks, depending on how often it's transmitting, or storing the data, depending whether you're going to transmit or store. And you can only read it once it's inside this special reader thing. So you can't even read it from a distance, right? So the other thing is I went to the Hitachi website then, and they're talking about this new small tag, and you can buy these. These are 2 by 2 millimeters square. And there's one that's 2.5 by 2.5. And you can read it with a 1 watt transmitter from 1 centimeter away. So, if you need a whole watt to create a strong enough field so that it can transmit it so you can read it 1 centimeter away, I doubt that you can have a tiny little chip that you can read from any kind of distance. That's only like, 0.05 millimeters square. And this is the equation that limits it all, right? Friese equation that says the received power is equal to your transmit power plus your antenna, basically your antenna gains, and then the frequency and the distance away you are from the transmitting antenna. So that this equation this part of the equation rapidly overpowers what you're doing here. And as a result, leaving very little left for your antenna to receive power electronics, and then also retransmit the signal, right? So anyway, that's it. Peter, go ahead.
Yeah, it's interesting, Kevin, because right around just before I retired, we were talking about installing passive tags on all the freight, and of course, how were we going to read it? And the idea at the time was, at least the working plan was, that every single loader in the system, aircraft loader or cargo loader, would have the transmitter to track this stuff on the gate, so that we would know exactly when the freight was going on the plane and when it was coming back off the plane. And then, of course, there would be readers at every entrance and exit of the cargo facility in order to know it left the building when, it got back into the building when, and all those kinds of things. But I had better things to do, and I retired, so I'm not too sure what to talk about. But it certainly was an interesting subject. Originally, they were talking about there was trouble with IATA and everything like that, because they did not want active tags on aircraft. Today it's probably a little bit different. I don't think they're quite so anal about it, but at that time they would only allow passive tags on board an aircraft.
That makes sense.
Mm-hmm.
Better safe than sorry, right? Sorry, Phil. I see Phil up there, and Dave.
If you want a real challenge with that hypothetical smart dust, why don't you try to model the antenna that's inside of it with a 4 neck 2?
Might go back into the conversation.
No, that would be Dave. That would be Dave. Not me.
We've come full circle. Go ahead, Dave.
I have to go, guys.
Oh, okay. See you, Mike.
Yeah, bye-bye.
Okay, later, Michael.
Yeah, Peter, that's very, very interesting that they would put tags on everything. Because, I started thinking, about if you look the spectrum around the airport, like there must be no space whatsoever. And pretty soon, all this stuff they're generating, all this RF from tags, at one point, it's all going to become noise. Mute. You're muted.
You're right. There is we did. I forget the name of the freight company, but we gave them permission to put tags on their freight, and then we placed sensors all throughout the facility, so that they would know when it was in and out and all that kind of good stuff. So it was already going. Where it hadn't progressed to was putting the readers on the aircraft loader, so you would actually know when it really went on the aircraft and when it actually came off the aircraft. And of course, when you're starting to ship things like we were talking, I don't know if it was this group or one of the other groups, but when you're talking about radioactive medicine, when did it actually get on board the plane? Was it late? When did it come off? Because the half-lives are so short on some of them.
And if you got all these transmitters, they're all transmitting. At some point, they're all going to mix and overlap and all kinds of stuff, and it'll be a mess. Eventually, it'll
don't forget, RFID tags don't transmit until they're interrogated, right? They don't transmit constantly, even the active ones, right?
But with all the stuff going on, they must be transmitted all the time. It's not as if they're randomly, but I guess this stuff happens so fast.
Walmart uses these extensively, right? I mean, all the skids, every skid has RFID on it, apparently.
Yeah.
And it's all out of, because, I mean, Walmart, whatever you think of Walmart is very good at one thing, and that is logistics. They're good. They are extremely good at logistics. So, and they apparently have everything tracked, like RFID tags all over the place.
But imagine all the bags and all the things going back and forth at an airport. It's pretty busy. I don't know. I'm just thinking out loud here. It must get, at some point, going to get to the point where all this stuff is just going to be just noise.
Well, it's pretty low wattage, isn't it?
It's extremely low wattage.
Yeah, I don't
like
think
in the microwatts. Like
yeah.
it's many dBms down. Sorry, go ahead, Peter. You were
many years ago. I think it was in the early '90s. We converted over to using laser scanners to read baggage tags in order to sort the baggage to appropriate chutes for the destinations. And the operational group was always demanding higher and higher read rates. They wanted basically perfect, which was pretty tough to do. So the suggestion I had at the time was, well, let's switch to RF tags. And so I did a little research on it. And if I recall correctly, it would cost about 25 cents a tag. And the corporation said, no, that's too expensive. And I keep thinking, well, if somebody's going to spend $800 on a ticket on an airplane, are they going to complain about 25-cent surcharge for an RFID tag? But anyway, I guess they probably did the math, 25 cents times how many passengers go through, and it's better in their pockets than than whatever.
Yep.
But it was available back way when.
Oh yeah, it's been around for many years. It's just getting cheaper, right?
And the benefit is you know exactly where your bag is.
If you know how to find it.
Well, the problem is though they don't work from a distance, right? If your reader is not right beside it, it doesn't help you.
No, but the last reader.
Okay, you know where the last reader it went through.
Yeah, so you've got where it was last time, as opposed to looking at, I guess, Well, now, isn't everything a barcode reader now, Peter?
Yeah,
It's all barcodes. In the case of baggage, it wouldn't work for that type of thing. It would only be strictly to tell the system where that bag is supposed to go, what chute it's supposed to go down. Where it really comes into some value is in the freight world. And now your freight customers can tell in real time where their freight is and where it's going. So if you put readers around the airport, you're going to be able to follow it and trace it. And in some cases, in some shipments, it's important.
Is that the same technology that's in every cat's ear and every dog's ear?
That's what I was going to ask, Phil.
I suspect it is, because they probably need some kind of reader that, I mean, I'm not familiar with it, but they probably need some kind of reader that they bring up to the body of the animal.
Exactly.
And it reads out a serial number, basically.
I think it's in the clear too, so it wouldn't be encoded.
Shoulders. It's in between the shoulders, not the ear.
Do those, hey Kevin, do those readers, is it like the near field stuff where you energize it?
Generally, yeah.
Energize it, then it transmits back?
Yeah, I've actually got one in one of my last, shopping sprees I went on when stuff was on sale. I bought one for my Arduino. It's got a little interface and a couple of tags and just to play around with, but I haven't powered it up yet.
Because
It
that's
occurs
how,
to me that the Hack RF might do it.
If it's got enough power, yeah. It's limited to, just a few dBm, I think.
Yeah, it's very low.
Yeah.
that's how key cards work, right? You take it up to your reader,
Yeah.
it energizes it, and sends a code back, and it says pass or fail.
Yeah.
One way you can observe that, you get a one-day pass for a bus, which is usually a little cardboard thing, and you put it in water and let all the cardboard disintegrate, and you got a little antenna around the outside, and you got a tiny little chip in one edge of it, and that's all you have left after you've evaporated all the paper off it.
Yeah, it's just an RFID tag. That's it, right?
Yeah.
I mean, everybody's got one in their credit card. Use tap in your credit card. That's an RFID tag. There's a loop antenna that runs around the inside edge of your card. So.
Yeah, many years ago, I got to work with a guy who he was one of Michael Osmond's buddies, and they developed this little recorder. And if you look at those key card readers, you could open them, put this in, attach it to somewhere in there, and it would capture. It was like a data logger, and it would capture every key card coming in. And the guy, we did a pen test at this facility, this place out in Guelph, and he actually installed it. And the next morning, he had a card. He went in and he sat in the director of IT's chair. He sat there waiting for him. Said, "You're late."
Yeah, that got his attention, didn't he? Wow.
Yeah, so it's these things. There's all ways of circumventing them. You just got to be clever, right?
Yeah. Well, yeah, you think outside the box a little bit and a little bit of technology, and away you go, right? So anyway, I figured that would be kind of topical these days with all the 5G COVID, tracking chip kind of stuff, that's going around. So
You see how
It really makes sense that someone might be easily sucked into that website you mentioned.
well, yeah, I mean, if you just look in the data sheet, it's like, yeah, okay, it looks kind of legit. But then I always check whenever I'm doing stuff, I always check the properties of the PDF, right? It tells you who the author was, what, if there's any copyright stuff, it's usually in there. And if you look at most data sheets, it's all in there, right? Copyright, Amtel or Microchip or whoever, all that legal kind of stuff. Nothing, not a thing.
Yeah.
And it was authored with some freebie PDF software. It wasn't, it wasn't like Adobe Distiller or some, proper, expensive commercial package.
Still,
Kevin, maybe you should post a link to the data sheet for us to look at.
I don't. Let me see if I.
You did put it in there, Kevin. Is that Paul McGuire?
Well, that's where the author was listed as Paul McGuire. So if you go back, that's I'm assuming he's the guy that did that, and it was listed as I think .com or something, but that website is gone. But I might have. I don't know if I kept a copy of it. or I just said, oh, this is stupid.
Based on that paulmcguire.us one, that does not look like the kind of guy who would read a fake data sheet.
Exactly. That was the
salvation from the fake data sheet, but
yeah, no, that was yeah, no, that was just silly. So you understand why I was a little bit doubtful that he might have created that data sheet.
that's fake news about fake data sheets.
You know what the big, the new emerging threat to COVID is now? We just got a memo floating around from the government that disruption in the supply chain.
Yep.
Their forecast, they're saying that terrorism, theft of vaccines, that's going to be one of the big threats now.
Well, they have armed guards on the planes.
And I thought about that.
Disruption of
landing in
electronic
Detroit,
components from China? No, we can't have that.
Yeah.
Well, you could see the guards on the planes, and when they were landing in Detroit, the first shipment that left and the first shipment that was going out, they were all guards around them.
Well,
I wondered if they'd already decided that it was likely someone was going to steal them.
well, it's how it's stored in hospitals.
Yeah.
That's the issue, because they hand it over to hospitals. How's
do.
it stored? How's it tracked?
It would be easy.
I thought this was going to be a fun meeting. Now you're depressing me.
This is a great meeting. I just really hope the RCMP aren't listening to any of this.
We're talking about threats and, hacking and all this stuff. It's in the same,
We should clarify this recording by saying we're a bunch of amateur radio qualified licensees that would never do anything illegal with this stuff. By the way, did everybody get the message from the ARRL over the weekend? If any of you are ARRL members?
Yeah.
You saw that? You know why that was, right?
No, what was that about?
That was on Sunday. There was reports that some of the the people that might have in the Duck Dynasty group that invaded the Capitol, because they got booted off all the social media, there was reports that they were going to start using radio to organize.
Okay.
And that's why ARRL jumped on it, and then they because I read that, and it's like 6 hours later I get this strange email from ARRL. It's like, oh, that's interesting.
As if anybody needs a reminder.
Yeah, right.
I was browsing 40 meters like this a week or two ago. I'm just going through the dial, and there was a bunch of guys talking, and there were like one or two guys, and they were singing, and they were just purposely disrupting the conversation. And I know I've seen that before, and you would think that that kind of stuff would go away, but still you're getting people who are purposely going in and disrupting stuff. So people using radio to go and spread their own message is probably realistic,
Were those the guys on 7.2?
Yeah, it was around 7.2, I think, or 7.
They're apparently legendary. But I think in this case, the ARRL was warning people not to plot crime on their amateur radios, which I thought was kind of interesting, because I'm sure the cops were hoping people would.
I suspect the people that are going to do that probably don't care about an email from the ARRL. If they're even members.
We had a light colonel in our amateur radio group that had served in Bosnia, and he came back with a milk crate full of Yaesu handhelds, and he presented them to the club as gifts. He says, we took these off of some people who didn't realize that transmitting in the clear on 2 meters might get picked up by a SIGs organization. And he said it's apparently still quite common for insurgents and the like to transmit in the clear on both hangs and whatever godforsaken country they're doing this in, not realizing that they're in the clear and can be picked up easily.
Yeah, and that and that we have SDRs that can record the entire band.
Not that we would ever use them for that.
No, I mean, even the government, right? There was a podcast. I don't know, Eric, I know you listen to the Ham Radio Workbench podcast. The one guy in there was saying that there's two big SDR vendors for the U.S. 3-letter agencies.
Yeah.
One of them is Flex Radio, and they make commercial stuff that scans like hundreds of megahertz simultaneously.
Yeah. He's always a little cagey when he talks about that topic, but yeah, you're right. I know for a fact, actually, I've tested. They do not listen to in the clear transmissions at U.S. border posts. That's for sure. So that's already been verified. So I can tell you that.
I'm just curious what you said to verify that.
Now, let's not go there.
This is going to be too many trigger words for this particular Jitsi session, I think.
Yeah, that's right. They're going to narrow in on Ahmed over there in the corner.
No, it's up there. There, that one.
Eric, don't tell them what we got in the trunk. Okay.
On your FRS on channel 21.
Anyway, yeah, that's so. Yeah, I figured that might generate a bit of discussion.
With regards to the 4NEC2 system, can that be run as a batch process for optimization?
Yeah, many times I leave mine running overnight.
Okay.
There is a batch. There is a way you could do a batch. If you go and you do the run, there is down at the bottom, it says to run a batch, because some of the, like I just running a simulation here, it took about an hour.
Well, by the way, I found the data sheet. If you want, I'll share the screen here for a second. We can just, I'll just show you.
It's interesting he would go to the trouble.
Well, somebody did, right? You know, I mean, it looks pretty official, right? I mean, you look at this, it's got like, you know, real, you know, electrical stuff, terms and everything that looks good. Look, it even's got like a ROM ID numbers and all this kind of things. So then you go down and you go, oh crap, I got to download it and look at hang on, I gotta save it here and then bring it up in Adobe Reader.
Just use Google.
Yeah, you can, if you just Google if you Google Hitachi Mu chip, and then I always just go file :PDF, because then it just strips out all the ads, and it'll pull up the data sheet. That'll be the first, that's the first hit. So then if I go on here and I go document properties, and in here, oh, this is different. Peter Jones.
I know what Peter Jones.
There you go.
No, you don't, Peter.
So, you know, there's no security, nothing like that. No, usually this is where they'll put like, you know, copyright information, that kind of stuff. But yeah, it's like, you know, world's smallest, you know, this is really the name of the file, like no part numbers, no nothing, right? It just, no revision levels, no dates, except for, you know, the date that it was created. So anyway, that's why it's like, okay, this is not real.
But imagine the number of people that could be sucked in by this thing.
Well, like I said, if you Google Hitachi Mu chip and data sheet, it'll come up. It's like,
I'd really prefer not to have it injected into me, because it would be a pretty large bore needle, but nonetheless.
Well, they're saying the chip size is 0.4 by 0.4. Yeah, that would be a rather large one. It's a lot smaller, or sorry, the other chips were a lot smaller, the 0.05 by 0.05.
That'll still leave a mark.
Yeah. But it's interesting. This one, they say, works at 2.4 gigahertz. I don't know I'm pretty sure a lot of these RFID chips work at much lower frequencies.
315 and 433, you said, eh? Those are the ones I know about.
Yeah, and some of them are even down, like there's a ISM band around 13. Some of them work like 13 megahertz, right? So. Well,
I know my very old garage door opener is in the 250s.
Oh, okay.
Something like that. It's the same. It's an old overhead garage door opener, and there's two versions of it. One's the 315 typical, and the other one's so old. Well, it's got a crank on the side of it.
Yeah. So anyway, that's are you ready for the microchip? Oh, is that Eric? You're on his website, Eric? Yeah. So anyway, hopefully that's a bookend to the last 4 years of conspiracy theories. That's my contribution.
I think that's where the data sheet came from. Is he has a $19 book on his website with that title? Are you ready for the microchip? So
Oh, maybe, yeah. Maybe he made it for the
seriously?
craft a realistic looking spec
Yeah.
sheet for it.
Yeah, he probably made it up to so that it goes in the so he could publish it in his book. Yeah.
There's no Q in the guy's name, eh?
No. Oh no, the real Q guys probably are in Mars by now with the rest of their buddies, probably, right?
Probably
That was
outfitting
one of
himself for a new horned hat.
Never a dull moment. Anyway,
It's been a hell of a day.
yeah. Anyway, I'm going to leave it at that before some 3-letter agency comes in here and shuts us down.
Hi.
RAC.
Okay, guys. That was Eric. Okay. So, has anybody got anything else before we wrap it up? I see Bob joined us a little late. Welcome, Bob.
You're muted, Bob.
Yeah, and Cherry joined us too late.
Whoop. Yeah,
Hi, Jerry.
okay. Hi, guys. Sorry I was late. I didn't realize Jetsy I can't get on my Mac, and I was down in the shack with the Mac, and also I can't get it on my Raspberry Pi, so I had to use my phone. So I've been listening. I always enjoy it. I'm learning a lot.
Thank you.
And
Hope you can keep coming back.
I will come I'm gonna have to bring the iPad down because I guess that's the only thing I can get this Jitsi on. But you guys keep warm up there.
Oh, we're not doing too bad.
Okay, and make sure you leave a hole. You leave a hole in the gate so I can get through.
When you need to escape, eh?
Yeah, yeah.
Yeah, it's been hanging around about 32 degrees here.
Oh, okay, okay. Well, that's anyway. That's it's 52 today, and nights have been just around 38 to 44. I'm trying to get it above 41 nights so I can finish camouflage painting my my tower sections.
Go ahead, Frank. You're muted, Frank.
Let me see. No, there we go. Just before I leave you guys, I wondered if anyone had visited Pete Giuliano's blog, and on there he has the recording of his presentation to the GQRP club in England. It was done recently and virtually. However, at the very end of that presentation during the questioning session, he gives credit to the Peel Amateur Radio Club and what we did with the Let's Build Something project. So it's an interesting presentation and a tip of the hat to us at the end of it.
Oh, that's cool. It's cool.
So we'll bid you all good evening and see you next month.
Okay. Enjoy the B&B.
Right.
Go ahead.
Interesting, because I was watching that presentation, but I haven't got to the end yet. I've been kind of breaking up over the last couple of days.
Okay. Well, if there's nothing else, we can say adieu, gentlemen. It was a good session tonight. We had 12 to 13. Sometimes we had 14, sometimes we had 15, but we had a good crowd. That's good. All ready, guys?
All right, thank you, and have a good evening.
Okay, have a good night and have
Night all.
rest.
See you all.
Take care, everybody.
Thank you for inviting us.
God, come in.
Come back
Good night.
anytime.
Stick around.
What a great session.
Good
Try
night.
and bring a toy next time. Good night.
Night.
Then there was 3.
Big screen, though.
Yeah, you get bigger screens.
No video problems now.
Well, there was one. It did stop off, so I think it is. I think that video automatically stops after a predetermined time.
Oh, the recording, you mean?
Yeah.
Oh yeah, absolutely. It's 1 hour. Yeah, that's definitely a given. I've seen that posted when I looked around. So it seems to be a limit on the public servers that meet.jitsi runs. So yet another reason to run our own instance.
Our own what?
Our own server for Jitsi meetings, and that wouldn't happen, right? Get more control.
Speaking of the videos, we should advertise where they are.
Re-advertise. That's true. I guess there's some people that don't even know that they're posted, right?
I don't even know. I suppose I
come on. I looked
on YouTube.
multiple times.
Yeah, you've posted a couple times there where the final.
But yeah. Okay, that's a kick in the pants for the YouTube channel. I get it. Yeah.
I wonder if we could put it up on the HB page.
Yeah, that's what I'm thinking. In 2 spaces, we could put it on the front page of the group's IO, and then we can put it in the I'll send something off to Peter to put it in the links in the HB section. Eric, I'm just thinking, I know you and I talked about it a little bit before, but I wonder if we could put a descriptor in for each one.
Right.
Now,
Yeah.
I've got copies of all our agendas, which might help with that.
Yeah, absolutely. Linking them up. When did you start doing the agendas? Has it been a few months now, or?
Oh yeah.
Yeah.
So maybe what I'll do is I'll summarize the descriptions in the agendas, and I'll send something off to you then.
Yeah, like a private YouTube channel is the way to go, because then people can comment. You can, get automated transcripts even, right, for free. I think there's services that'll do that for you. So, and then you're searching for things. It's all there. So,
okay.
So a little homebrew YouTube. It doesn't have to be I guess it might as well be public, right? So it's not like there's anything that we discuss that's sketchy on this.
Well, there was one, but hopefully you edited it out.
Good.
I know it's past the 18th now. I guess did you hear anything from Kelly?
No, I was going to leave until Friday, and I was going to call him on the weekend.
Oh, okay.
No, I had a couple of weeks ago. I had sent him an email. This is when we were trying to put the list of how many people. We got 19 of 20 kits. I sent him an email, and I says, "Are you going to be taking one of the kits when they come available?" And he didn't reply. So I copied and pasted my question to reply to him. And I think it was like a day later, he replied yes. And I said, okay, I assume so. So we got 19 people taking 20 slots, which leaves us 1 to build. I said, now, how's it going with the update? Have you been able to work on it? And I didn't hear anything. So I opened the email that I sent to him, and I copied